Yes, welcome back again. I'm sure everybody is fine after this short break. I promise you guys I'm not going to talk much this time around. I'm sure you are fine. You love the formula sheet. You've seen how important it is. The very important formula that we are using here for this question. The formula sheet, remember, it contains a number of formulas, but I want you, at least for today, be aware, well aware about the analytical geometry formula. We are going to work on exercises now. Exercises. This is not time for us teachers to talk to you, but it's time for you to actually work on exercises now. So I'm really going to do very little talking. You guys will be working on exercises. Look at this question here. It still goes analytical geometry. You don't necessarily have to draw to save time. You don't necessarily have to draw the diagram to save time, so that we can use the little time we have meaningfully for 2 or 3 exercises. It is written here in the diagram below: K, the points 5 and 4, L, the points -5 and -2, and M is the point -1 and -6, and you can see them drawn here. Now, the important thing about this topic, analytical geometry, be aware that we are going to use a lot of polygons, and in this case we have a triangle, which is fine. Our points are already plotted, the vertices of triangle KLM in a Cartesian plane. Good. Determine the midpoint of MK. MK, the midpoint. The midpoint of MK, we go to our formula sheet. The formula for the midpoint, we cannot afford to get this incorrect. We have the formula sheet, we copy from the formula sheet, and then we write the correct formula, and then we do the substitution. I'll give you time to work on the answer for that one. The midpoint of MK. Good. I'm sure you are fine. Check with the person next to you just to make sure that you are fine. And then we have that. We all agree 2 and -1. Remember the midpoint, these are the coordinates. So the other one is the value of x, and the other one is the value of y. The coordinates of that midpoint. Now the midpoint, they call it n. So you can see that n is somewhere here, where x is 2, but y is -1, and we are happy with this because we can see that it's possible that x can be 2 here. It's possible that y can be -1 there. So our answer is not really far off. It must be a correct answer. Good. Now we go to the next one. It says the gradient of LM. The gradient of LM, here is the point L. L is -5 and 2. M is -1, -6. The gradient now here. LM, the gradient. I'm sure you have started working already. You check from your formula sheet the expression for the gradient, and then LM. I'll give you some minutes to work on that gradient. the formula sheet. Here is the formula for the gradient. It's written on the formula sheet. I am actually looking at the formula sheet myself, you know, just to make sure that I have the correct values in the right place. And then here on the question paper, you write n can be x1, y1, lm, x2, y2, depends. You can write that with a pencil so that you do the correct substitution. And the gradient, I'm sure we agree it is something -2. And we are happy with that value negative because we look at a line LM. Look at that line LM. Do you see the line LM? The gradient must be a negative gradient. You see that it is from the second quadrant of the Cartesian plane to the fourth quadrant of the quadrilateral. So the gradient must be negative. So we are happy really with negative 2. That's very good. You are doing very well, guys. And then the other question there says the length of LM, and leave the answer in simplest form, in simplest set form. The length. Now the length, remember on the formula sheet we have the length of what? It must be LM. The length of LM. How long is LM? The distance between 2 points. Do you see that? The distance between 2 points. The length of LM. On the formula sheet we have the distance. The length is the distance. There is our formula. We write it and then we do the correct substitution. LM. I'll give you 2 minutes to work on that. I'm trying to push you hard now. Remember, this is a question that you don't waste a lot of time working on the exercises, but you need to be very accurate, very correct, because you have the formula sheet. You can always check from the formula sheet if you have the correct formula. Length is the distance. Distance is the length of LM. Good. The length of LM, they said try to have it in simplified set form. The length of LM, or it can be any other better than that, in simplified set form. We can still have it as 16 multiplied by 5. I'm sure 16 multiplied by 5. Let's check on our calculator here. 16 multiplied by 5, it gives us 80, so it's good. And then the square root of 16 is 4 the root of 5. Good. So that can be the simplest set form in this case. Good. I'm sure the distance, just be careful to do the correct. It's very important for the substitution. This substitution is very, very crucial. The correct formula, the substitution, very, very important. It helps us. The simplification there, the simplified set form, those are very, very important marks We really don't want to lose them unnecessarily. Very important marks. The equation 1.4, look at 1.4 there. The equation of LM. Remember what we said for the equation, the equation of a straight line, you must have a gradient and a point. LM, do you have the gradient of LM? You need to check that. And I realize question 1.2 there said the gradient, so we already have the gradient. It makes things much easier for us now. So somewhere up there we answered the gradient of LM. So we don't have to redo the gradient again. The gradient of LM. We don't have to redo it again. We already have the gradient. I'll give you time to work on that. The equation of LM, and LM is a straight line. LM is a straight line. There it is. So the equation of that line, LM, it's a straight line. The equation of that line, LM. LM, 2 points there, but for the equation, the formula sheet says just have the gradient and 1 point. That point you call it y1, x1, y1. That point you call it x1, y1. 1 point, choose it between LM and use it as your x1, y1. Good. We are doing very good progress. We can have it as LM, the equation. Look, I have the expression. I just simply copied straight from the formula sheet. I copied straight from the formula sheet. There it is. I took it as it is from the formula sheet because I know it is for the equation of a straight line. The important thing, I checked, do I have the gradient? M is the gradient. Do I have the gradient of LM? I realized that number 2 there, I calculated the gradient of LM. Remember, we calculated number 2, the 1.2. We calculate the gradient was -2. So we take it as it is. We substitute it in here. It's for LM. We put it in there. We take any point. Some of you might have taken this point L. Some of you might have taken this other point. So that I took L, I said y1 is 2. There we go. Y1 is 2. Y minus 2. And x1, I said x1 then must be -5. And look at my substitution there. X minus -5 is x1. From there, once you have done the substitution, which is very important, then you do the simplification there. You simplify there, I'm sure it is plus, so when you multiply it there, I'm sure it will give you -10. Then y is equals to -2x, and then you have here -8, I suppose. When you have the additive inverse of this one, it becomes +2, then this might be our equation there. Good, you are doing very well. this ultimately becomes the equation. You check with the person next to you. We are doing very, very well. Good. The equation, now listen to this one. It's a bit of an interesting one. It says the equation of the line parallel. That line is parallel to LM. And that line passes through N. I want us to look at that one again. It's quite interesting. And you like it when you hear parallel, because we have talked about parallel before. It is said that that line is parallel to LM. And it means there's a somewhere here, there might be a line somewhere here which is parallel. Somewhere here there might be a line here which might be, I'm just throwing it for us to at least understand what is happening here. That line is passing through N. Remember our N? Through this point N. But that line is parallel to what? To LM. Good. And that line is also a straight line. Do you realize that? And once it is a straight line, it means we come again here. Formula sheet says anything the straight line is this. Have the gradient, have a point. Now let's check. The line is parallel and passing through a point. Parallel, remember what we said about parallel? It's a straight line. So you can go already to your formula sheet. But very important, we said parallel lines, the gradients are the same. Do you remember that? Once it says parallel, it means this gradient is the same as that gradient. And what was the gradient for LM? The gradient for LM. Do you remember the gradient for LM was how much? -2. It means what will be the gradient for this line which is parallel? The gradient for LM, you calculated it, you said it's -2. Now the gradient for this line, because the lines are parallel and you have a point here, then you can find or calculate the equation. I'm going to leave that to you. Please look at it. Talk to your friend next to you there without making noise for others. Don't make noise at all. I know sometimes your teacher is out, they are busy with other things, they are teaching the grade 10s, the grade 9, the grade 11s, but the grade 12s, you are given this session and you are sometimes all alone in there. Don't make noise, never make noise for others. Let's work together here. You are calculating now the equation of the line. That line is parallel. Good, you did very, very well. The emphasis, you know, I had to underline it. It's on this parallel. And we agree that if this gradient is -2, this gradient also will be -2. The two lines are parallel. The line is parallel to each other. The gradients are the same. They are just the same gradient. If here the gradient is -2, the gradient there will also be what? -2. So you have the gradient and a point. You can find the equation. Here we are. We have the gradient. We also have what? A point. Our point is what? x1, y1. There we are. Our point is x1, y1, a gradient and a point, so we can find the equation there, which is very good. Do you realize what happened now there? Now we do the substitution, which is crucial, important for us, the substitution. We say for the gradient we have -2. The substitution, we say for the gradient we have -2. Our y1 is the point here at n, is -1. And look at how I put that -1. -1, it must be in the brackets. Y minus, but the y1 is -1 in the brackets. And x1 there, we check from our point x is 2. So x minus 2, we simplify, and then that becomes our. You guys are marvelous. You are doing very, very well. Please don't forget parallel. What we have learned about parallel lines, the gradients are simply the same gradient. And the last question there is the inclination of LM. LM, the angle of inclination. I'll leave that to you to work it out for just the remaining 3 minutes before it is 9:30, so that we can go on with another exercise. At least very important, we are okay now with the length, the gradient, the coordinates of the midpoint. We have seen parallel lines. What do we mean? What does the gradient, how does the gradient relate to parallel lines? Good, we have done very well. The angle of inclination there, tangent theta, because it also comes from the formula sheet here. Tangent theta is equals to m. M is the gradient. M is equals to tangent theta. Tangent theta is equals to m. M is the gradient, which is good. Ne? There we are. We take it as it is. We put it in here. Tangent theta is equals to m. And m, remember, is what? The gradient. We have calculated it. We don't have to calculate it again because we calculated the gradient earlier on. We have already calculated the gradient earlier on, so we don't have to do it again in 1.2 up there. So you must be careful about these questions because one follows from the others. The gradient was calculated there, -2, so we don't calculate it again. We just put m -2, and on our calculators, on our second function, tangent -2, there we are. And then once it is negative there, we subtract it by 180 degrees, so it is 116 degrees, 57 degrees, 116,57 degrees, because the angle of inclination, remember what is a positive angle. It moves in an anti-clockwise direction. Here it is. The angle of inclination goes in an anti-clockwise direction. It will be the angle there. It's an obtuse angle. There we are, 160. Good. We are doing well. Good progress. I'm happy with the progress that we are doing. We're getting more and more confident now on answering these questions. We can look at this other exercise here. Let's look at this other exercise here, which talks about the same things. There we are, question 1. The same exercise. There we are. Right. There we are. Look at the information given there. Look at the information given. You see what is nice about this section on analytical geometry? You are given polygons to say this is a triangle, this is a polygon, whatever kind of a polygon. Work on it, look at it and try to answer the questions that follow there. Now here ABC is a quadrilateral four-sided figure, four-sided figure with vertices A 1 and 6, B 3 and 0, C 6 and 1, D 7 and T. Take note of that. We don't have a value there, 7 and T in a Cartesian plane. Very important, it's mentioned that AD is parallel to BC. Ooh, we are happy. Parallel, we already know what we have learned about parallel. Once it says parallel, we know that the gradients are the same. We are happy about that. We really want to keep that. We are excited. We are looking forward what the question will be saying on this parallel. Parallel. We love parallel because we have learned something about parallel. Good. When the quadrilateral is drawn, can you see the quadrilateral? Let's check on the questions that follow now. The first question, calculate the gradient of BC. More confident. BC, the gradient. Where is my formula sheet? I just go to my formula sheet with a smile now. The gradient on the formula sheet. The gradient of BC. Much better now, much better. Good. I'll give you time to work on that. Out of this 20 marks, 15 marks, we really want to get more marks. We can't afford to make a mistake here. We want to make a mark in this examination. We can't just leave everything unanswered. We want to answer everything. And at least we are going in that direction now. Give answer to everything. Good. I see everybody is smiling. I wrote first my formula. I took it from the formula sheet. The formula, I check it. I'm sure that once I have it correct, what is important for me now is to make correct substitution. B, C. I can call any of these to be my x1, y1, x2, y2, the way you want it. Anyway, it's not a problem. You can choose any of those to be x1, y1. The way you want it is fine. Do you see that? Now it becomes easy for me to substitute. How much is y2? Y2 is 1. Here it is. I put 1, y1 is 0. I check. I just write them as they are to just make the correct substitution. Good. And then I'll see what do I get when I simplify. And we all agree that we have simplified nicely. There is the gradient, and we are aware that the gradient is the gradient of BC. The gradient of BC. Good. Determine the equation of AD in the form of y is equals to. Good. AD. Do you see where AD is? That line AD. The line AD. Do you see that line? The equation of the line. Where's my formula sheet? Formula sheet. Where's my equation? Here it is. The equation of the line. The equation of the line. So first thing, write the equation of the line. But now the formula sheet said the equation is this one. You need to have a gradient and a point. A gradient and a point x1, y1. Isn't it? Do we have the gradient here? AD. How do I calculate the gradient because it's t now there? No, we look at parallel. Parallel. Oh, if the gradient of this one here, if the gradient of this one, BC, we have calculated it here. We know the gradient of BC. The two lines are parallel. I can go on myself. I'm giving you this time to work it out yourself. We have seen a lot of information here. Parallel, it's important. Once we see parallel, we know that there's something that we know about parallel. Gradients are equal. Good. I'm sure we've done a lot of progress on that equation. Determine the equation of AD in the form of that AD that is. We are not interested on the point D. We just are happy that we have the gradient. There we are, our point. We use this point that we already have there. Y1 is 6. The gradient of BC, they are parallel, so the gradient of BC is the same as the gradient of AD. We have calculated the gradient of BC in the first question, so it is 1 over 3. We use it. 1 over 3. X1 is 1. So we didn't use this point here because this other point, we don't have the value of y on the coordinates. So we avoided it. We use this one point that we have here as well as the gradient because the lines are parallel. You did very well. I'm happy about your progress. Then we simplify here. We try to simplify. The additive inverse there. The additive inverse plus 6. Then our answer 1 over 3x. We can use our calculator to work out the answer there. I'm sure our answer is something plus 17 over 3. Good. So that becomes the equation that we have there for the line. 1.2, the equation that we have there. Determine the equation AD in the form, and it's very important to emphasize that it must be in the form of y is equals to. It is indicate the equation must be in the form y is equal, so our answer must be y is equal to that, the gradient x as well as the value of c. There we are. Good. We are doing very well. Show. The other question now says, show that t is 8. Remember our t there on our quadrilateral. Show that t is 8. Show that t is 8. That this value t here, the y value at this point D, show it that is 8. How can we show that? But remember the power of us knowing that the two lines are parallel. That's a very important information. We can't ignore it, that the two lines are parallel. So what do? We can use the gradient. And what do you know about parallel lines and the gradient? The gradient of this line is equal to the gradient of that line. Good, I'll give you some 2 minutes to work on that as well. Good, I'm sure we are fine now. The gradient show that t, the point t will be equals to 8. The value of y here, t on this d coordinates, t will be 8. Show us that. So what do we do here? Because we realize that we have parallel lines, then we know about parallel lines that the gradients are equal. So you see the gradient of BC, the gradient of, let me go slightly up like that, the gradient of BC is equal to the gradient of AD. Is that fine with everybody? It's perfect, because we know that the gradients are the same if the lines are parallel. So the gradient of BC is equal to the gradient of AD. Good. But the gradient of BC, we already know the gradient of BC. Where is it? We calculated here. Number 1, remember, the gradient of BC, we calculated it, and we all agreed it is 1 over 3. Good. So the gradient of BC, we write it in, it's 1 over 3. But now the gradient of AD, we substitute, we first go to the formula sheet. We like the formula sheet. The gradient, where is the gradient? The gradient on the formula sheet, this is the proper equation, formula, expression for the gradient. You see that? We use it for AD. So you can write it with a pencil to say, this is your x2, y2, this is your x1, y1. Write it with a pencil. It makes things much easier for your calculation. Do you see that? The gradient, therefore, we say y2 is how much? Is t minus y1 is how much? 6. All this is divided by x2 is how much? It's 7 minus, and then x1 is how much? 1. You see, once you write them with a pencil on your question paper, it becomes easy for you to take them as you substitute in the formula there. Then I'm sure we are trying to simplify from there onwards. 1 over 3 is equals to t minus 6. 7 minus 1, it's 6. Good. Then suggestions, what do we do? Yes, we are fine. We can cross multiply here. That's one simpler way to go through it. It can be 3t minus 3 multiplied by 6, it's 18. Then 6 multiplied by 1, we have 6 there. I'm sure we are fine with that. Then we simplify further. 3t is equal to the additive inverse of negative 8 becomes positive this side, 18 plus 6, we have 24, and I'm sure at this stage now we can divide on both sides. Remember, this is an equation. What you do on the one side, you must always do on the other side, so that it remains an equation, equal. Good. So this one into that one goes once. 3 divided by 3 is 1. We are not cancelling. 3 divided by 3 is 1. So we have t there. The coefficient is 1. Good. T is equals to 24 divided by 3. I think here we're having 8. We can confirm our answer with a calculator, just to make sure that we don't lose that important mark. There it is. It says 8. We are happy. So t is 8. And really we have shown what the question wanted us to show. The question, if you remember, it said, show us that your t, the answer for t will be 8. Show that the answer for t is equals to 8. And we are fine. We have made a calculation. It was a pretty long one, but we can simplify it further. Easier than this, cut other methods. I just wanted everybody to see the proper calculation. Take your time. Be precise. Be very accurate with your calculations. Good. We are running out of time now. We can go to number 1.4. Calculate the lengths. The lengths of AD, BC, AB. The length of AD. And now we know that with D, our coordinates, now we know it is 7. We have shown that T is 8. So what is the length? How long is AD? How long is BC? How long is AB? The length of all those. Calculate the length. I'm going to leave that to you, the length of that, and we know the length is the distance between 2 points. The length is the distance between 2 points. Good. The length of that. Length, the distance between. You see, there's a clear distinction between the length, the distance, the gradient, the equation of a line, as well as the angle of inclination. So this question now on the length. Length is that square root d, the distance between 2 points. Good. The length of that, I'm going to leave that to you to quickly do now. Good. We are fine. I'm sure with the lengths, I left that to you to do. The length of AD, the length of BC, the length of AB. Good. That's nice. I want us to go to show that AB is perpendicular to BC. How do we show that AB is perpendicular to BC? In mathematics, we don't decide just by looking at the sketch and say, no, these things are perpendicular, or no, they are not perpendicular. We have learned earlier on that once you talk of perpendicular here, there are a number of things that we must think of. Perpendicular, the product of the gradient. The product of the gradient must give us -1. The product of the gradient must give us -1. Then it means they are perpendicular. If we can show that this angle is 90 degrees here, then the two lines are perpendicular. But because we are working with gradients mostly here now, we can take the root of the gradient, the product of the gradients. If you give us -1, then we are fine. I'll give you some time here. The product gradient of AB, if we can find the gradient of AB and the gradient of BC, if the product can give us -1, then we know that the two lines are perpendicular. That's what we have learned earlier on. I'll give you 2 minutes as well to work on that. I'm rushing a little bit now. Good. You did very well. You did very well. The gradient of BC, we already have it. We don't have to recalculate it again. Remember, earlier on we calculated the gradient of BC. It was 1/3, 1 divided by 3. Good. Now we need to calculate the gradient of AB now. It has not been calculated as yet, so we just did it now. AB, the gradient of AB. You note down which one is x1, x2, which one is y1, y2. You decide anyway, it's fine, as long as that will help you to do the correct substitution. So here it is, the gradient here is -3. Now we have the gradient of AB, which is very important now. The gradient of AB, when we multiply the gradient of BC, let's see what we get. The gradient of AB is -3. The gradient of BC is 1/3. But when you multiply these two values here, numbers here, when you multiply, you get -1. Ooh, we are happy. We have shown that the two lines are perpendicular because here the product of their gradients give us -1. So we are good. Learned a very important thing. Perpendicular lines, anything perpendicular, the gradients of the two lines then must give us -1. Determine theta, the angle of inclination of BC. Here it is. We know BC, this line, theta, angle of inclination. We can deal with that one. The formula sheet, I always would want to go to the formula sheet just to make sure of my formula here. M is equal to tangent theta. M, it means I need the gradient. The gradient of what? Of BC. I already know the gradient of BC. I equate the two and then I will have the value I'm looking for. Good. We are doing very well. And then you can just have a look at this exercise. There are a number of exercises. I'm sure your teacher also will give you. I'll encourage that you go to your teacher and then the teacher go to that question 1 of analytical geometry. Say, your teacher, can we look at that question 1 of analytical geometry? There are concepts that we have learned. We want to make sure that we are fine with them. Look, the other question here, you can draw it. And the questions are familiar questions. I'll give you 5 minutes. Don't answer the questions. Just draw and you'll answer them later. The first question says the gradient. We have learned a lot. Find the coordinates of D. The coordinates of D. And this line is equal to that other line segment. They are the same in length, meaning D is what? Good. D is our midpoint. D is our, it's not written, they just gave us that this line side, the distance here is the same as the distance this side, so it means D is in the middle, it is the midpoint. Good. So we already know, they said just only here, find the coordinates of D, but grade 12, we realized, no, D is the midpoint, it's at the middle, at the center. Calculate the equation of the line CD, the equation of CD, the equation, you know, you always now and then go to the formula sheet, so we know what we want. When you say the equation, we know the formula sheet will assist us there. Show that triangle ABC is isosceles triangle. Good. You can ask your grade 11s as well, your friends in grade 11s, remind us what do we know about isosceles triangle. What is very important, what do we know about isosceles triangle? And then I'm sure the distance formula will assist us then to answer that question there. It's a rhombus. If ACBF is a rhombus, you see now these polygons still come in the four-sided figures. It can be a triangle, it can be any quadrilateral. A little bit of information that we need to know about these quadrilaterals or polygons.